Yeah, go ahead. All right. So, does everybody understand the logic problem that we have up there? So you have 3 bags. One of the bags has 2 blue marbles. One of the bags has 1 blue, 1 white. The other one has 1 white. Okay? So we want to know the probability you draw out a white. What is the probability you draw another white right afterwards? So you're not putting it back in. So you draw out a white, put that marble aside, you have 1 marble left in the bag. What's the chance that it's white again? 1/3? 1/2? All right, so let's work backwards. What's probability that we draw out just a white marble stepping back a step? 1/2. Okay, is everyone okay with that? So does the marble in the bag know that it was sitting with a white or a blue marble? Phone's away, please. Seriously. 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 Does the marble in the bag know that it was sitting next to a white marble or blue marble? No. So one of these events had been taken care of, right? So, God bless you. This event here or one of those took place. Okay? Now let's change the category a little bit. So we took the 1 white marble out, and I don't know, we put it in our pocket, walked away, left 3 bags on the counter. Okay? You realize you're 4 miles from where you were just doing this activity. You're like, why do I have a marble in my pocket? And you throw it away. You show back up to the location. Show back up to the location. The 3 bags are still sitting there. Yeah. Maybe. So you show back up, it's 1/2. So are you following my category? So we pull a marble out, it's white. We're like, oh, cool. We already knew that there was blue, 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 white, white, white. We pull a marble out, it's white. So the probability we drew that first white marble was 1/2. 3 out of my 6 marbles happens to be white. We put that marble in our pocket. We leave the 3 bags on the table. We go away, we go over to McDonald's and get a shake or something. We're like, why do I have a marble in my pocket? You throw it away. You come back and you're like, oh, that's right. I was in the middle of this logic problem and I just thought it'd be fun to leave these on my table. So how many marbles are left that would be white in our scenario? Okay. So we have a 2/5 probability. There's 5 marbles left. Huh? Well, right now, what's the probability that I have my marble sitting there. I had 1/2 probability. Now it's no longer, I'm taking out that 1/2 probability because I'm making the event no longer independent. Okay? Or it's an independent event. It's not dependent upon it because I walked away, took the marble. I come back. In the 3 bags that are sitting there all next to each other, 2 out of 5 of those marbles still have to be white.
You should have told us that first, because if you draw white, then it is 1/2. That's the possibility. But if you said
right, this is why I'm saying you're going to the store. You do this, you go to the store, you totally forgot about that probability.
before you had that, you wrote draw out a
So draw a white and a white. Okay? So let's do this. Draw a white. First white. 1/2. Draw another white. 2/5. Or 1/5 nailed it. Good. Yeah. Okay, I have 3 bags. Bag 1, 2, and 3. Reach in one bag, not looking. Sweet, I have a white marble. I walk away. There's now 5 marbles sitting in those 3 bags.
You take it out of the same bag, and since there's only 2 bags with white marbles, you can take out the third one that has the blue one, because that's out of the probability now.
Yeah, it just leaves the bag with 2 white marbles.
So you have 1 marble, 2 marbles, 2 marbles, right? Regardless of color. Now you reach in the bag, you're not like, oh wait, this is the one that has the 1 marble. So being the probability was originally 1/2, and then you pulled out that white, leaving you a 2/5 chance. The probability of the first event times the probability of the second event have to multiply together. So the probability of the first event, the probability of you drawing a white, has to be 1/2. So you reach in that bag. So you either, in that bag, you either have a blue or a white, correct? And then the next bag could be white, white, or blue, white. The last bag has to be blue, blue. So you have two events that, because the marbles don't remember each other, one is independent of the other, so you're going to multiply the 2 events. No, there's always 3 bags.
For the top one to have a white marble, it would have to be 2 blue and 1 white, which doesn't say that. So.
Right, you have blue, 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 white, white, white.
And then it says out of the same bag.
Right. Oh. Okay.
So it's 1/2.
Oh, so should we? Hang on. You might be onto something. Hang on. So what you're saying is because I'm going to draw out of the same bag,
It's guaranteed to have. It's either one of those.
it's either blue or white, right? Ah. So I think what we have to do is we actually have to subtract 1/3 from this. So 3/15 minus or plus 5 out of 15. I'd say it's closer to an 8/15 probability. Because I'm eliminating the 3rd bag.
Wait, is it 1/3?
Because you're reaching this 8 bag, and once you take out one of the whites, then it's either.
That's what I have. 8/15, right?
She asked if it was 1/3. It's either one of those 2 bags, and so once you reach in, you've decided it's between 1/2.
Ah.
Which is
It means
Ah. Well, 8/15 is close to 1/2, but I'm going to think about it. I'll think about it. Little other argument. Last one I want to talk about, just kind of a fun one. You know the show Let's Make a Deal? You guys ever seen the show? No? You've never seen it, really? Gosh, you guys got to stay home more. Let's Make a Deal works this way. Let's make a deal. They have 3 curtains, and they call you up. And they say, hey, would you, behind one of these curtains is a car, and behind the other 2 curtains is, a bad prize, like a bale of hay and a trash can. So you have a car, and then you have a bale of hay, and you have a trash can. So let's say you make the choice. Hey, do I want to, pick one of these. Pick one of these. So let's say a person says, hey, I'm going to pick door number 1. Okay, sounds good. So you're going to pick door number 1. Now, they're not going to open door number 1 right away. What they're going to do is they're going to open up one of the other 2 doors. That is either the bale of hay or the trash can. No, you're fine. Person next to you, though. Texting. You're not? Oh, I'm sorry. I saw the glow coming down from the window, and I thought it was your light. I'm like, what the heck? All right. So you pick door number 1. They open this door, which is a bad prize. Do you want to switch doors? Ooh. Ooh. No? Go with your gut? All right, before we answer this question, let's say we have 1,000 doors. And behind one of the doors is a car. And the other 999 doors are trash cans. So you pick your original door. So say you still stick with door number 1. They open up 998 other doors that are all trash cans. So that leaves you your original door and the other door. Do you switch now? No? Well, I mean, they will purposely open up the ones that don't work. All right, what about if we had 1,000 or 10,000 doors? And they say, okay, pick a door. So, Lenny, pick me a number from 1 to 10,000. 900. All right. So door number 900, you think the car is behind. So I am going to open up 9,998 of the doors, leaving door number 900 closed and door number 6 closed. So the chances of you winning are behind one of those 2 doors. Are you willing to switch?
Well, I mean, it won't put it in your favorite change.
We have 1 million doors. 1 million doors. Luke, pick me a number from 1 to 1 million. 3,007 is chosen. Okay? Now we're going to open all of these non-winning doors. We're actually going to open 999,998 doors are now open, in which you're looking at 999,998 trash cans. And then you have your curtain, which is 3,007, and another curtain closed. Are you willing to switch now?
No.
So it's all based on the number. All right. Let's go with the population of the planet. We have the population of the world, 6,500,000,000 people. Still with me? And let's say and 1, and you are the 1. So what you got to do is you get to choose. You and one other person. So is that other person could be your mom, your dad, your sister or brothers, right? So you get to choose. You get to choose. Whoever you choose is going to get $1 billion. $1 billion. Okay? So you choose some person, and we tell you that 499,999,998. We open. Okay? Now you're hoping that this $1 billion prize goes to one of your family members, right? Because if it goes to one of your family members, you're probably set. Do you think? You think that'd be okay? So you chose some number out of 6,500,000,000. And that person behind that question mark is going to get $1 billion. And in this is going to be part of your family. Okay? We open this many doors. Within those doors that you have seen open, you notice that you have family members in there going, oh, I'm sorry. But you also realize that your father or your mother, whoever your favorite family member might be, is not chosen. And then you have Vladimir Putin. That also was. Okay, so behind one of the doors, one of the two doors left, so you chose this one. And then this is the other one that's closed. Behind one of those is your father. Behind the other one is Putin. Switching? Or are you sticking that you got lucky and your dad happened to be behind your first choice? You're 1 in 6.5 billion chance. Yeah.
It's 50-50 now.
It's 50-50 now. I'm just trying to get you to switch doors.
Okay, we switch doors.
Yeah, okay, cool. Why? Because I want you to switch doors. Why do I want you to switch doors? I want you to realize that the probability that you choose originally your father was the 1 in 6.5 billion. Yeah.
That was the 1/2 chance because there's only 2 doors?
It could be. So back to the original question, which was this one. Do you switch doors?
No.
No.
Why? No, because you it's a less.
No, you're not going to like it. You're not going to like it.
Stick to your guns.
You're not going to like it. So, if you chose and did not switch, you have a 1/3 probability that you win. If you switch, once I've opened the door, you have a 2/3 probability you win.
That's not true.
It is true.
Totally not.
It's not if you switch. It's if once it's crossed out, it automatically makes you 50-50. Why? Why?
Because I will purposely open a loser door.
So you're still right now. If there's 3 doors, and you open one, and there's nothing in there, and there's 2 doors left, then you have a 50-50 chance.
Go to this door. We had 1 in 1,000 of winning originally.
You still have
If we don't switch, we still have the 1 out of 1,000 probability of winning. If we switch doors, we have a 999 out of 1,000 chance. Winner. 998, excuse me. Always switch.
So
Always
if I'm on a
switch.
and I switch and I don't win. So it's like that.
You can blame me.
What was that briefcase game when they always offered you to switch?
Oh, who won? Yeah.
Deal or no deal?
Deal or no deal?
Should you have switched?
I would have. I definitely would have switched.
That's why they don't take your math teacher.
No, but you can switch on that show, right? Remember, he says, okay, one of these 2 cases, let's say you got down to the millions gotten. One of these cases has a $500,000. Were you lucky enough to choose the $500,000 case originally out of the 30 cases, or should you switch? You should switch. Pretty lucky guy?
I might stay with my original.
No, there was
Yeah.
always those
What if
times.
they don't know probabilities either? Like, what if they don't know which ones, like, where the bad ones?
Don't you think the announcer of the show would know? Or somebody with the...
I'm saying if this was done with, like, someone being like,
Oh,
okay, so this is completely randomized. Do you want to switch? It's like, I chose 2 numbers, yours and someone else's.
I will, tomorrow I'll pull up the, show you why to switch the 3-door thing. And it amounts to all the same rules. No.
It flows.
My whole concept, I won't find it right away. Then I'll get mad and I'll start cussing. And I've been recording the whole time. So tomorrow we will pull up the doors and take a look at why it works. All right, let's talk about Page 236, 1 through 15 odd, if you don't mind. Page 236, 1 through 15 odd. Now, I saw some of you, you did the classic move of, I'm just going to write down the answers, which, great. What questions do you have on 1 through 15 odd or number 19? Number 3? So number 3, I have this. Okay. First item. Is there any undefined terms up here? Is there any undefined terms? Do I have a variable and a denominator? Do I have a variable under a square root sign? No. So I don't have to worry about any undefined terms right off the bat. Let's clear the denominators. So I'm going to take all 3 terms and multiply all 3 terms by what? 20. Good. I'm going to multiply this by 20, this by 20, and this by 20. 4 goes into 25 times, so I'm going to get this. 5 goes into 24 times, so I have this. Make sure we distribute the negative on this. And then 15 times 20 is 300, I believe. Did I do that right? Okay, again, we didn't have any undefined terms in the beginning, so we're okay. Let's solve this problem. I'm going to distribute over here. So I'm going to get 5x plus 10. Negative 4x times each of those equals 300. Let's combine like terms. So I have x and negative 4x, so that's just going to give me 1x or x. And 14, so these would have given me 14. So if I subtract the 14 to bring it over, I'm going to get 286. Is that right? So that's my answer. And I would say that answer is going to work if I pull 286 over plus 2, that's 290. 290 over 4 minus 285 over 5 should give me 15. You can check it on a calculator later. That's number 3. What else do we have? What else do we have? Hey. I'm sorry? 19? 19. Uh-oh. Okay. Do we have denominators? Do we have denominators that have variables? So we have undefined terms up here. So I'm going to split the screen. So let's take care of the undefined terms first. So the undefined terms, 5x plus 20 equals 0. So that's going to give me 5x equals negative 20. So x is equal to negative 4. Okay, so that's one answer that's not going to work. I have x squared minus 16 is equal to 0. So x squared is equal to 16. Square root. X is equal to plus or minus 4. Okay, so we satisfy, so I'm definitely sure that negative 4 doesn't work. And then I have x minus 4 equals 0. So x equals 4. So 4 and negative 4 cannot be part of our solution set. They give us undefined terms. Is that okay so far? Okay, so we have that off to the side. Now underneath the problem on the left board, I'll go ahead and work out the problem. What I want to do is I want to clear our denominators. So what I'm going to do is this. Realize this is the same thing as x plus 4, x minus 4. Agree? This is the same thing as 5x plus 4. Do you agree with those two denominators? So what should I multiply all 3 terms by that will eliminate all my denominators? X plus 4. What else? X minus 4. What else? 5. So 5, x plus 4, x minus 4 is going to be multiplied by all of my fractions. I'm going to multiply this by 5, x plus 4, x minus 4, 5, x plus 4, x minus 4, and 5, x plus 4, x minus 4. All right, start canceling a few things. So 5x that's going to be 1 times x minus 4 minus x plus 4x minus 4 are gone. 1 times 5. And then that going to cancel that, so that's going to give me 1 times 5 times x plus 4. Is that okay? Do the simple math, distribute here, that's going to give me x minus 4 minus 5 equals 1 times 5 is 5, 5 times that, 5 times that. So that's going to be x minus 9 is equal to 5x plus 20. Let's subtract the x. Let's subtract the 20. What is that, negative 29? So x is equal to negative 29 over 4. Did I do that right? I think so. Sweet. Hey, here's the nice thing. This is what x is equal to. X could not equal any of these. Was that our answer at all? No. So do I have to worry about what they couldn't equal right now? I just needed to make sure that if my answer came out that way, that it wasn't 4 or negative 4. Any other questions from the homework?
Number 13.
13. Yeah. Negative 69 over 14? Let me make sure I wrote it down right. 19, x plus 20, x squared minus 16, x minus 4. Yes.
Oh, it's x minus 9.
Say that one more time.
Okay, so
Shh.
you have one, like that part's good, the first part, but it's supposed to be equal to 5 times the quantity x plus 4 times 3 because you have to multiply the whole equation by 5 x plus 4 x minus 4 because of this product. Does that make sense?
Oh, you know what? There was supposed to be a 3 here. And that's going to carry through. That makes that, so that makes that 15x and 60, 15x. So that's 14x, that's 60. So that's 69 over 14. Is that what you said? It was a negative? Okay. I didn't write the right problem down. I made a 1 on top. Thank you. There was another question. Was it 13? Okay. Number 13. All right. What should we worry about? Yeah, let's worry about our denominator. So we know that x is not equal to 1 and x is not equal to 3. So as long as my answer doesn't come out to that, we should be all right. But if they come out to that, then we have to say with a no solution. Hang on, I gotta. Excuse me. Thank you. All right. So let's we have fraction equals fraction. Let's do some cross multiplication. Or products of the mean equals the products of the extreme. I like cross multiplication better. Just strike the pose in front of the camera.
Yeah.
Good man. So I get that by cross multiplication. Is that okay so far? Distribute over here. I get 2x squared minus 6x equals 5x minus 5. Let's bring everything over here. What is that? Minus 11x plus 5. Probably could factor it. Should we do a dream method, see if it works? 2x, 2x. We know that 2x times 2x is 4x squared, so we're going to have some trash. 5 is dreaming about being 10. It wants to be negative, negative. So the factors of 10 that add to be negative 11, if they were both negative, would be 10 and 1. Trash on this one, throw the 2 out. And then this one, I can solve that easily. That's x equals 1/2, and x equals 5. So my two answers, 1/2 and 5, are either of those numbers 1 and 3. So my answer works. Yep. Number 5? number 5. One half plus 2 over x equals 1 cleared plus 3 over x. What sticks out right away that my answer can't be? 0. Okay? So my answer, x cannot equal 0, so we have to keep that in mind while we work the problem. I have denominators of 2, x, 3, and x. So if I clear my denominator, if I multiply each term by 6x, all right, so that goes in there. That's a 3x. That's going to give me a 12. That's going to go in there. Gives me a 2x. That gives me an 18. Packing your can over there? Huh?
I got bored.
Oh, I understand. I'm sorry. I'm trying to entertain you more. Subtract 2x. I get x. There it goes. That should work. Yeah, I used to chew. God, I loved it, chewing. Best habit I ever quit.
Oh, what? Juice.
Who's got the fatty bumbleaddies in here? All right. We good? Pass them on in. 5, 4, 3, 2, 1. I'm recording now. All right. We are going to start solving these when they have absolute values. Oh, joy.
I gave you the warning.
What warning? I didn't warn anybody. All right. So when you do these, what you need to do is you have to realize you have both positive and negative components. An important part of these is make sure if you plug the value back in, it's true. So if I take 8 and plug it back in, is the absolute value of 8 8? Yes. If I take negative 8 and plug it in, what's the absolute value of negative 8? 8. So is 8, is that okay?
Yep.
Do both those answers work? Perfect. All right, next problem, we're going to do the same thing. So I have x plus 3 equals 4, and x plus 3 equals negative 4. Let's solve both. So subtracting 3. Okay? Let's make sure our answers work. 1 plus 3 is? 4. Is the absolute value of 4 4? Yep. Let's take negative 7, plug it in. Negative 7 plus 3 is? Negative 4. What's the absolute value of negative 4? 4. Does it work? Both answers work. Let's try the next one. I have x minus 2 equals negative 3, and x minus 2 is equal to positive 3. So you have the negative and positive components. Solve it. So I'm going to add 2. So negative 1 minus 2 is negative 3. The absolute value of negative 3 is 3. Is 3 equal to negative 3? Nope, this one don't work. All right, plug 5 in. 5 minus 2. 3. Absolute value of 3. Is 3 equal to negative 3? What can you tell me about the solutions here? There you go. No solution. Okay? Let's take it up a notch. So you have 2 in front of the absolute value sign. Treat that 2 as it's being multiplied times the quantity. You could distribute over, or you could divide both sides by 2 first. That's going to give you this. Why does it smell like baby powder in here? Smell like baby powder in here. Someone change your diaper? I'm kidding. All right, so I got x plus 5 is equal to negative 5. X plus 5 equals to 5. Subtracting 5. Plug negative 10 in. Negative 10 plus 5 is negative 5. Absolute value of negative 5 is 5. That don't work. Plugging 0 in. 0 plus 5. Absolute value of 5 is 5. So this also has a no solution. So sometimes you should look for, if you have a free floating around radical, or not radical, a negative sign. Because if that does take place, it might convey a no solution. Yeah.
What does it take for it to be a solution?
If I plug it in, it makes it true. Okay? Those wouldn't be true. Like if I plug 5 in, I get 5 minus 2, which is 3. Absolute value of 3 is 3. 3 is not equal to negative 3. Okay? I think that might be it. That's all I got. Your assignment, for those of you who choose to do it, or just copy it out of the back of the book, is today's Tuesday, right?
Yep.
Page 238, 79 through 97, odd.
Jordan, you know you have this conversation right now.